Hey, Kelsey, good to have you.
I'm happy to be here.
How's it going?
Fantastic.
Very good. You know, when I first read your name, it was under your Twitter post. Every infrastructure team wants to have a platform as a service, but it has to be rolled by themselves. Do you remember that one? I just looked at your 29,000 Twitter posts, but do you recall this one?
I remember that one because when I wrote that one, I think I was coming out of, I spent a lot of time at Google Cloud Platform, and we do these whiteboarding sessions with platform engineering teams all around the world, like big and small. And the same thing occurs, right? Every team, if you ask them, they want deployments to be easy. They want to have some standardization across the organization, all of these things. And then when you show them a platform that does that, it could be Heroku, it could be App Engine, it could be Cloud Foundry, you name it. And they all say, yeah, but, right? And then they have this long list of things. And then you quickly realize that everyone wants a platform, but one caveat, it has to be built by them.
Absolutely. And it's so crazy, right? At this year's PlatformCon, I think they're expecting 35,000 people, watch parties all over the world. That's up from, I think, 20,000 last year. It was 7,000 when it started. That was 22, I think. And that's sort of, that explosion is so crazy. Why do you think is that? What are the key drivers that, like, why is everybody jumping on that train? Do they want to make money? Is there like, is the problem getting more nasty? What is it?
Yeah, I mean, I think for the last at least 20 years of my career, once everyone was kind of forced to have a company website, right? 15, 20 years ago, your company now has to have a pretty decent online presence. There's going to be now this concept of a user and an account, even if you're selling insurance. Pre-internet, you go to the insurance agent's office, get your insurance, call it a day, and you're done. Now, there has to be a portal, there has to be a user profile, instant quotes, some type of relationship, maybe even a reward system. And once you get into that moment, there is no universal piece of software that you can buy as a platform component that does all these things. So when I sum up platform engineering as it stands today, it's taking whatever's available to everyone off the shelf. This could be Linux. Your job as a platform engineer is fill the gap between what's available and what your company actually needs. And I think this is the reason why the needle keeps moving, right? So when it was just Linux, if we were just get to very concrete terms, if you just install Debian and that's it,
Yeah.
maybe you're fancy and you click the enable vim and SSH, and that's it, that's installed.
Yeah.
And if you hand that off to your company, they're gonna be like, hey, we use Java. Okay, so now you got to go get the JVM. We need this type of configuration because we use IPv6. All the things you're gonna do from a raw Linux install until it's usable by the organization, that whole thing, that's platform engineering. And you can take this to the cloud, you can take this to databases. So it's not surprising to me that the majority of people doing this kind of work have now started to rally behind one common way to identify ourselves, platform engineering, because it's such a broad topic and it literally is the foundation for all the other stuff that we do.
Interesting. Yeah. And one observation that I have, and I'm curious to see whether that's something that you would mirror, is that because I mean, nothing about platform engineering is new, right? But this latest wave that we're seeing, right? There's sort of the perception, like, let's do the things that everybody does. And one of the things that I'm observing is that we're doing a lot of optimization geared to one user group, the developer. And we're talking a lot about developer self-service, cognitive load, like you name the current buzzwords. But I sometimes have the feeling that overly optimizing on one group goes at the expense of other groups. So to give you an example, I'm seeing these hundreds of developers clicking in portals and creating crazy amounts of resources. And then I'm always wondering, like, guys, who's taking care of those? Like, do we have to rethink the user if it comes to whom we're serving?
Yeah, the whole developer thing, I think honestly, the industry in general is being of a little lack of better word, dishonest. Right now, the industry kind of feels that the developer is the most important component when we think about the software lifecycle, right? These are the people who take the business ideas and turn them into the products that people can touch. So software have been very impactful. It's been very powerful. So when we start to think about whose job we want to make the best in that chain, then we think about the developer. We put them center focus. One positive way to look at this is who is a developer. And depending on how you look at it, a developer could be an operations person. It could be a DBA that is developing the schema and the performance tuning of your database, or it could be that developer that opens VS Code and types text into an IDE and then goes through this software supply chain to get into production. That is like the typical technical person that we see in the movies. That's the technical person that you think of when you think about software, but it's a little bit misleading. That person, if you look at their tool belt, if you look at what's in their tool bag, they have their own tools of choice and they have their own workflows of choice. So you can't sell them a universal solution. They don't have enough insight to do all the jobs that needs to be done. For example, the internet is typically out of the pure view of the developer, even though they depend on it to do what they do. It just sits in the background, does this thing, BGP packets are flying around, but things just work. And the way a developer interfaces with the internet is through libraries, right? Import Express.js, import some HTTP thing, and the developer has a very clean interface between that one of 100,000 components they need to deal with via a library. The challenge, though, is that a lot of people are talking about building stuff for developers, but don't have a library or an interface. So when you say, hey, we're going to make infrastructure friendly to developers, you're kidding yourself. It's not a developer-friendly thing. The best you can do is give them an API, some type of contract to say, hey, infrastructure is complex. There are lots of knobs that you can twist. Based on what you need, we're going to simplify it to some degree and give you an API that you can use as a contract. But it's still on the developer to decide, do they want that to be a VS Code plugin? Do they want that to be some command line tool that's super flexible that supports their programming language of choice, something like Pulumi comes to mind here? Or do they want something that's like declarative, like Terraform? Either way, this is the huge surface that you give when you say self-service. You're telling the developer that every particular concern that they want to express is going to be at their doorstep. And that's just too much of a surface area for them to get the whole set of layers correct. And so I think we do over-index, but I do think there's something nice about this. If you were a network engineer and you want to make something developer-friendly, then you know if we get to the API component, the API component could be bind to the socket and traffic will flow to you. That's all you got to do. And then your libraries can implement that particular system call. You bind to port 8080, port 443, and then somehow magically the network shows up. That's a really nice API to expose to a developer. So I do kind of like the developer kind of being the end state, if you will, but we got to make sure that we are clear about who's the developer. It could also be operations people. The cloud gives operations people an API so they can develop the layer at which they work.
And I always think that platform engineering is a multiplayer game, right? Different persona groups. You mentioned the operation team, also the security team, right? From a large enterprise point of view, like how do we make sure we don't have humans read through repetitive Terraform code to see that, that one line that we changed. And so it has to be a balance. And I think we always have to look at the change that we're making right now, the thing that we are seemingly making simple and self-service. Does that actually, are we just shifting the work somewhere else? Or are we really bringing business logic that's so sophisticated that we're making a meaningful change to every...
I'm be honest with you, I kind of get in trouble for this take. I actually think silos are fantastic. Silos are beautiful, especially if you put an API in between them. And people are like, no, we should be collaborating. It's like, you're not telling the truth. If you go to the airport, you do not want the airline to shift left anything. I don't want to fly the plane. I don't want to clean the plane. I don't want to fuel the plane. And I don't want to load the luggage on the plane. Yeah. I just want to use the app, express where I want to go. You tell me how much that costs. I get a ticket on my phone and I sit in my assigned seat and you do what you do. Airports do what they do. There's a ton of infrastructure science and physics involved in keeping planes in the air and landing safely. I don't want to do that. I'm a passenger. And I think when it comes to most infrastructure, that's just how it works. Like, let's just simplify it really quickly. I write software. It binds to a port. It gets data. It puts data in the database and returns a response. Do we need to collaborate every single day on doing that activity? Absolutely not. There should be a clean, at least a happy path of how to accomplish these things. And look, most people have never met most platform engineers that support them. You've never met the person that works at the electric company. You've probably never met the person that works at the low levels of a cloud provider. Why? Because they expose an API with a very clear and consistent contract. So if you're on the platform engineering team, I do think it's an anti-pattern to force everyone to learn Terraform, to force everyone to learn infrastructure as code, especially to do very simple things. Now, someone would say, well, no collaboration. I'm not saying that. I'm saying if we're going to collaborate on anything, let's collaborate on something that we can't do yet, right? I would like to start using a caching layer for my app. We don't currently have one. We may need to collaborate on the proper configuration. Do we want to use Redis or something else? But once all of that collaboration is done, what is the final API for me to communicate that I would like to use Redis? And that API could be as simple as when my app starts up, it reaches out to Vault and identifies itself, and Vault returns a set of credentials and an IP address so I can interact with the caching layer. Wouldn't that be a beautiful kind of end state? And all of these tools below that line, those are just tools we use as platform engineers to helpfully get us to the point where the contract can be that straightforward.
Yeah, and Jason Warner, who was at Heroku and then GitHub, said to me, and that's I'll not forget that, if you have a setup where dev and ops have to have transactional conversations, you're failing, right? There is nothing wrong with separation of concern. And I'm like, the Amazon guy, Werner Vogels, said this, you build it, you run it. And I think this is one of the biggest misconceptions in the last 15 years. It really feels like we're the only industry, since the Stone Ages probably, that have step-by-step reduced the separation of concern and the specialization. Why do you think is that the case? Are we over-indexing on the buying power of the individual developer? Are we afraid that we are being abstracted away? What is that fear?
If we were to consider software an engineering discipline, we're almost the only discipline where you can fix the mistakes fairly quickly. In the physical world, you cannot behave like this. People will die. It's very dangerous. But software, we can be a little reckless. We can build a particular feature that doesn't really work, only works under certain situations, and deploy it anyway. Why? Because we could just deploy it again, or we could just remove it. And I think given that, it's shaped our engineering culture on the software landscape. And so this idea that, hey, you're asking me to add a shopping cart to the site. I've never done this before. I have no idea what I'm doing. Oh, you on the QA team? You've never tested this before. You have no idea what you're doing. And SREs and support, you have no idea how it's supposed to work. But you know what? Since this is software, we're going to do it anyway. We're going to ship it. We're going to call it agile, right? We're moving fast. Look, it's a gift that we are able to do this. I think this is why we have so much software. This is why we're able to iterate much quicker than other, industries. And so I think we just have to be careful how we walk that line. So some people think, hey, to me, there's this idea that there's a difference between waterfall, where you plan a lot up front and then you execute, versus agile. But I think when you come to any complex thing, if you've never done it before, you're probably going to have a lot more upfront research, prototyping, before you can just start doing agile on the back end for something that just needs iterative improvement. So I think the big thing here is that when it comes to current engineering practices, some companies find themselves in this world where they're taking for granted and almost abusing the flexibility. And so you end up with the world where it's like, hey, I came into work this week. every app is written in Java. I just went to a conference and I want to write the next component in Rust. And the whole team is like, we don't know what that is. We've never managed that, but it's just software. So have at it. Go make your own build pipeline. Here's access to a few of the servers. You got Kubernetes. Do whatever you want. You build it. You run it almost because you have to.
Yeah, because nobody at that level of, it's so heterogeneous but nobody can run that for you, right? So you're cast to actually do that. They have no choice. Absolutely. That's an interesting point. Standardization, right? These days, everybody is talking about standardization, harmonization, and one of the things that I find most sparking, if you go to a team and say, how many Cloud SQL databases do you have? And they go like 500. In staging, 500 Cloud SQL databases in staging. How many, like, we're looking at this now, like, how many different configurations, how many of those 500 Cloud SQL databases are configured in a unique way? And they say like 500. Every database is configured in a specific way, and then there's a Terraform file for each. And you go, okay, so how many ways are there to configure Cloud SQL and staging that make sense and bring a material difference to the performance of the application? And we could have an argumentation, right? It could be maybe 5 ways, maybe 10, not 500. How far should we push this? Is standardization good? Can standardization be dangerous? What's your feeling here?
Oh, it's I put standardization, based on your scale, I'm going to put it on the dangerous end because you can't standardize until you really understand all the scenarios. So at best, what you can do is have a baseline. So right. A baseline could be, we've read the docs. This is our first time doing this. We're just going to go with the best practices as a baseline. And we know how computers work. The baseline works when you have 10 customers, 100 concurrent customers, and everything is fine, no worries. So that's a good starting point. And you've seen this over your career. The best practice will change as the industry has collective experience. And ideally, the vendors and the project maintainers go and update those docs and say, hey, we don't use these encryption ciphers anymore. Those are less safe. This is no longer a best practice, and it's deprecated. And over time, we will all coalesce around that, and that's what we'll start doing. Now, for your company, remember that whole gray area, the difference between the baseline and what we need? Hey, I'm in a highly regulated industry. The auditor came and said, I must use this cipher. So in that moment, I need to configure my particular SQL instance this way. But I'm running on a newer AMD chip that has an accelerator. So we're going to go with this particular configuration of that security component. So if you look at this, we're probably in the hundreds of millions of permutations based on your time, location, CPU architecture, whatever, and also the apps downstream. Your clients and your servers will be different. They may not have a client that can make that connection and then negotiate that security. So now what? So I think really when it comes down to the configuration component, we have to make a bunch of decisions above and beyond the baseline. And those decisions tend to support everything backward and forward. And it's endless. So when I think about this whole platform engineering thing, maybe the component we don't talk about enough is we have to gather consensus on what right is. And based on that, we have to serialize those decisions into the tool or config of choice. And I think that's where all the friction is, right? Hey, we've made a bunch of decisions last year. We've gotten the stack perfect and Heartbleed. Heartbleed. What? So it doesn't matter what your decisions were before. You now are being forced to make a new set of decisions, and you don't really have time to get consensus across the whole team. Some people fixing Heartbleed led to other issues. Is that the right set of trade-offs? And how do those work with 1,000 previous decisions you've made? That's what makes this so hard. So to standardize, we don't have enough information to say rubber and asphalt work well, so every car gets tires. Yeah, you can standardize on that. But if I don't know where you're going to be driving, sometimes there's asphalt, sometimes there's clay, sometimes there's just dust and sand. maybe that's not the best decision. And unfortunately, that's where we find ourselves in software and engineering.
And you need to find that common denominator where you can standardize without threatening productivity, right? I talked to a guy at the Google Next. There was a platform engineering roundtable, and there was a guy from Intuit, and he made a very clever comment. A platform surface area can only be so large because it can only span a specific set of very similar applications in order for it to have a lower common tech denominator that makes sense. You cannot. I often have some people come to me like, "Hey, we want to build a platform across like 6 different groups, 3,000 developers. It's VM, Kubernetes, and then there are also data pipelines." And I'm always, guys, you should there's no way. Nobody's ever done that. So that's so important, right? To keep it small and look for that common denominator. Is that a good way of looking at it?
Yeah, I think in production, it's just if we're being very clear, it's like, hey, we have a good baseline. The baseline keeps moving, and we just consider that the happy path. We try to evangelize that throughout the organization. That's a good time to start building these libraries that go on top. Like, let's say you're using gRPC and you have a really good metrics and monitoring solution. You may actually implement libraries that get generated when people do their builds that automatically integrate with Prometheus, for example, because you kind of standardize that Prometheus is flexible enough. We have some good patterns. We have some good experience in production. We're going to go one step further and build on top of that foundation and start to do things like auto-generating things inside of our proxies. It's beautiful. But here's the thing. That's the happy path. Let's just say that the team really needs to use a different time series database, or they're forced to push metrics to a third party because that's what the customer requires. Well, how flexible are you? You could put if statements in your library, but we know how the evolution works. For that one use case, they're going to have to break glass. They're going to have to import a second library, shim it in between, and basically duplicate their effort to probably send things to where it needs to be. If this is a one-off, we may not standardize on this one-off. We might say this is only for this one app, maybe until we see this 2 or 3 times. That's when we'll decide to update our gRPC code generation pipeline, or even waste our time creating and maintaining a library to ensure everyone in the organization can send metrics to this third party. But I think that's kind of the beauty of what we do. We get to, try new things damn near in real time. And if they do become, and if they're worthy of standards, then we turn them into libraries. And in the case of some large organizations, like in the case of Google, becoming the foundation for HTTP 3, right? A lot of the work they did for YouTube, right, to optimize sending video, modern internet practices, you take what they did and you level it up to an RFC. And then it becomes a standard for the world. And it doesn't mean it's perfect, but I think that is the natural evolution of making progress.
Yeah, fascinating. It's really an 80-20 thing, right? It's really about understanding that you can't standardize everything, and some things just have to float freely, and some people should not be forced to go on a platform. And it's again, and that's and then again, platform engineering is such a cultural thing as well. There's no technical solution to it. It's really about feeling the right cutoff point and designing that and making it a conversation and observing and not being.
The other day, I was seeing a modern data center being built.
Yeah.
And on the ground floor, it can move.
Good.
And our conventional design is like when you build a building, at least for people who've never done it like me, you think that it needs to be rigid and stiff. And the thing is, when things are rigid and stiff and the earth moves, they break and fall over and bad things happen. And so if you're going to house a building with cooling, lots of power, and a very expensive hardware, you need it to be flexible. And I think a lot of times when we're doing platform engineering, maybe after a few years, we feel like we can standardize everything because we think we have all the right patterns. And this is where that tension comes in, right? The whole reason for like this whole DevOps movement, developers versus operations, balancing standardization versus moving forward at a speed and pace of innovation. I think as platform engineers, we need to know it's going to change. We need to know that there's going to be a good reason to break something, even though I can't see it yet. And the people who operate that way, I think those are the best platform engineers that say, hey, we're building this foundation to be stable, yet flexible at the same time. So when something new comes, we're ready for it. There's still a process, but we know that we're never going to be done with this thing. And so we built the platform to support change.
Right. And we're offering something, and you can take it because it's great and because it's fitting to your need. But honestly, if you want to, but you choose us because it helps you, right? If you need something else, you want to branch off, you think you can serve yourself better, that's fine, right? We have to prove ourselves because we're making a difference. And that is so important that we don't get back into this model where we're enforcing things to say like, hey, it's our bet, right? You're bad. You have to swallow it as it is.
The thing I like about this whole platform engineering movement, we're moving into the product design cycle phases, even for operations. That's my big takeaway from this evolution. We're not just system administrators processing Jira tickets anymore. We're now saying that this platform, version 1.0 of it, we can give it a fancy name if we want. And that thing has these features and capabilities. And when people want to use our platform and they can't do something, this is your moment to put your UX hat on and study what they're doing. If someone is doing a one-off, can I see your scripts? Can I see what you're clicking on? And then you have to make a decision from a product perspective. Do we want our platform to be able to do that or not? And if the answer is no, then you got to let them keep doing what they're doing. If the answer is yes, then you got to retrofit the old and new world together and make it seamless for multiple use cases.
Yeah, absolutely. Now that I have you, I have one question that actually I was asking myself, and you have your Google post. There is this tension in the industry still between on premises. I'm running my own, let's say my own data center, the hybrid world, the cloud providers. What's your prediction if you have good platforms that essentially unify interfaces? Will we see less movement into the cloud? Will we see more hybrid roles? Will we see a renaissance of the data center? Is there something in the bush, or is everything going to the cloud?
When I looked at my career, as I got better at my job, I demanded more money for what I did. I got more expensive over time. So human capital tends to get more expensive over time. And you combine that with power and efficiencies. And remember this thing we just went through with standardization. You have to go get NetApp, Dell, Juniper server, or Juniper top of rack switch. Then what are you going to do for internet? What are you going to do for power? Do you get this PDU? There's so many decisions just to rack a system. And when I hear cloud, what I'm hearing is standardization.
Yeah.
How much can you actually run a VM for? My guess in 2024, as we're recording this, probably about the same price if you include the human capital as what the cloud provider can do. This is why a lot of people are just more like, I only run on-prem when I have a good situation or use case. I need the data to stay where it is. Maybe it's a factory floor, or we're just not comfortable putting our data there. No problem. Then you run on-prem. But I do think it's getting harder and harder to match the capabilities of a group of people who are spending billions of dollars every year trying to make something better. Typically, you're given an IT budget that has to last you 5 years. You can buy the latest and greatest HP blade system, and you have to keep it for 5 years. And then the cloud provider is trying to invent new hardware accelerators. They're doing the latest and greatest for Intel for memory encryption. One day the auditor is going to come by on year 3 of your hardware cycle and say, hey, the industry's moving towards encrypted end-to-end, including memory, where our hardware doesn't support that. Come back in 2 years. That may not be an acceptable response to deal with the landscape. So I do see that if the cloud providers continue to get better, I do think a lot of people, today we don't build our own servers. We buy them from Dell or HP or whoever. Maybe a lot of people will choose to get their infrastructure from a cloud provider. But the other side of this coin is, I don't think there's going to only be 5 or 6 major cloud providers in the future. I do think at some point, every country will probably have to have a premier cloud provider because of what GCP and Amazon were doing 10 years ago. You can get a lot of this stuff now closer to off the shelf. Like I was just at a conference and I saw my friends at Oxide Computer They build these fully integrated, and we haven't had a new hardware company in a long time. But when you see this rack, it literally looks like the same type of things that a hyperscaler would have.
Yeah.
They will sell it to normal people.
Yeah.
You can manage the whole thing using Terraform or APIs.
Everything's set up, right? Just plug it in.
So what is the cloud? At some point, I think you're going to have cloud capabilities wherever you want them. So instead of trying to build your own rack yourself, you'll buy some Amazon Outpost, plug it in, and you'll have a cloud console. I think the evolution between cloud and on-prem gets erased. And at some point, everything you buy will be at the same expectation. And if we can just get there by 2030 from what we had in Amazon in 2012, I think a lot of people will feel like the difference between cloud and on-prem has gone away.
Yeah, absolutely. Yeah, that's such a fascinating, race, or almost to the bottom, because it feels like at some point it's commoditized to a degree, right? But then again, I'm always, the Germans that I talk to will say, we have high security standards. We want to manage these things ourselves. And I always think, like, guys, do you really believe you're going to get close to the security level that Google has? Like this. So.
Well, let's pull on that thread. I've worked at a cloud provider, and here's what Germany will say. Germany say, by law, you will have to have that data center here. 51% of our citizens will manage that data center. We will have the understanding. We will rack the servers. We'll have all the knowledge. And we know what happens after that. Once that group of people understand how this works deeply, then they will become entrepreneurs, and they will become branches of the government, right? The people who manage the water supply, the people who manage the electricity. I think based on where we're going, computing will truly become a utility. And there will be no way in the world that a government wouldn't have the skill set to at least get to where we were in 2015. That will have to be a new baseline, and it will happen, right? Germans can build cars. They're going to have to learn how to build data centers too.
They have to. I mean, these guys have I'm German, so I can say that, like, we have a long way to go. Definitely. So, Kelsey, like, going into the next year of this trend, and I'm becoming, which is I don't think I would have ever dared to admit this 5 years ago, but I'm becoming an increasing fan of the Gartner hype cycle, because every time I'm looking at this, I get like, man, are these guys accurate? So we're, I think, at the sort of peak of inflation, but we're really getting closer to I think they call the trough of disillusionment. Like, what is your prediction of how that will feel like, the trough of disillusionment? What are going to be the core drivers why we're hitting that? And what can organizations do today to not get trapped?
I think if we think about this, imagine if everything just worked perfectly. You download software and ran your apps. People will be extremely bored doing this work. The salaries will go from, in the US, let's say salaries are 300, 400K. They will go down to 70K because anyone could do it, because it just works. Just follow the instructions. So who would want to do the job? The need for a platform engineer will be reduced greatly. If the demand for innovation, meaning customers don't care, every app is roughly the same. They all look the same. They all work the same. There's no difference between this insurance company and this insurance company. Great. So then I think what happens to our industry overall is that it's no longer this thing where we need experts of people making the impossible occur. Everyone can do it. So then innovation has to shift somewhere else. And maybe that's where everyone will go that wants to actually push boundaries on something. So we kind of need this kind of ability to push boundaries. In terms of the hype cycles, to me, nothing changed. When I first joined, it was all about Linux versus Unix versus AIX versus Solaris. You open files this way, you can do Corn Shell or Bash. Everyone got excited. Linux is the future and the rest will go away. Linux went up, and then we got bored. Then it just started working, and we don't think about it anymore. And right when that hype cycle was coming down, I got the next one, virtualization, no more bare metal. You would just virtualize all your servers, and we were all super excited until it started working. And maybe cloud gave it a resurgence. Virtualization on steroid, but with the real API this time. But humans just do this. When we get a little too bored, we find something to be excited about. And honestly, I don't know if we would actually be motivated to keep pushing boundaries if we didn't have these hype cycles to surf on, right? New people enter our industry. All of this stuff is new for them for the first time, right? Like configuration management, we get it. There's an API, pick a language or a DSL, configure the thing. We're done here. But new people are born all the time. Someone will come and say, I got a better way of doing this thing you've been doing for 20 years. And I didn't cut my beard today for a reason, because I want it to be a gray beard today. And what happens is when we've been doing this long enough, we have no idea why these kids are so excited about a thing we were doing 20 years ago. But it's that excitement that motivates them to the point where they'll say, I know we already have Puppet Chef and Ansible, but why not Terraform?
Yeah.
And then someone is cooking up the replacement for Terraform as we speak. And so I just think this is a natural way to keep us interested, keep us all engaged, keep us motivated. And hopefully we'll just keep making all of these systems that exist today a little better and a little better. And once we finish those things, we'll move on to something else, where space travel, something else will become the biggest thing on our radars.
That is a very good way of looking at it. There is a paradox in economics called the Jevons paradox, and that means that when the rebound effect is greater than 100%, then you have a situation where it's exceeding the original efficiency gains. And what that means is we're so afraid that, and we were like 20 years ago, we're so afraid like, we'll be automated away. There's nothing we have to do. Productivity and automation increases. But the thing is, we're moving faster and faster and faster. We're serving billions of people. Sophisticated things. We're now putting like language models on top, and then very soon we'll have to communicate with space stations. There's so much to build, right? And I think we have to stop being afraid that we are obsolete, but see it, as you say, as a chance of actually evolution and driving change and finding that next interesting thing, and together making this a better place to live. And so I think we have to be a little less afraid and a little more embracing of what's to come.
The transition is tricky, so I understand the fear. If you are a DB2 admin, right, you manage IBM DB2 as your database, and the Oracle people come and say, we have more features, we're more compatible with other tools and systems, and you got to make a decision in that moment. Do I learn Oracle or do I stick with DB2, because that's what all the jobs are, and that's where I'm going to make the most money, and that's what I'm good at. But then this transitional period is weird, because during that transition period, the people who bet on Oracle may or may not be right during this transition. But if they're right, all new database projects become Oracle projects. And you're kind of left out of that kind of work. And if you're not paying attention, there are very few DB2 job openings. So if you've had a 30-year career at one company and you want to switch careers, you're like, hey, how come no one's using DB2 anymore? And you're like, well, Postgres or Oracle, that's it. And so what happens? So for the DB2 people, the transition is rough. They got to literally start over, learn some new skills, and hopefully what they've learned in the past applies going forward. If we were to double down on this, maybe multiply it by 10 for society, what happens if we get hyper-productive, fully automated? Does everybody need a job? Do we just work because? Or do we re-architect the way we think about money and society in general? I think that's the tricky part. So some companies, they get automation in place. It's all right, now let's lay off some people. But maybe that's a mistake. We should go to examine the backlog of all the things we didn't even attempt to try, because we were doing all of these low-level tasks that are now fully automated. Hopefully, companies and society in general figures out that thing that, hey, once we've automated things away, can we turn our attention to something that we don't even have answers for?
Yeah. Great closing statement, Kelsey. Thank you for having a conversation where we didn't talk about AI a single minute. That's much appreciated. Thank you for being here today and being a spokesperson for platform engineering. Thank you very much.
Awesome. Later.